Good morning, and thank you for joining us here in Washington at NASA headquarters for today's update on the Space Shuttle's return to flight. I'm Dean Acosta from the Office of Public Affairs. Joining us this morning are NASA Administrator Michael Griffin and Associate Administrator for Space Operations, Bill Reedy. I'd like to remind everyone to please wait for the microphone before asking your question, and don't forget to tell us your name and affiliation. Again, thank you for taking the time to join us. Now, here's NASA Administrator Michael Griffin.
Good morning, everybody. Actually, we can't keep meeting like this for just a routine launch slip. Now, we are here to let you know officially that we will be moving the shuttle Discovery's return to flight launch window or launch from the May, early June window to the mid-July window. We're doing that as a result of over the past week and a half, several reviews to include a shuttle design certification review for the changes which have been made for return to flight, and then a Delta design design verification review on debris issues held down at JSC this week. And as a result of all that, and looking at some of the open analysis items and small fixes that we need to make, and some issues that arose during the tanking operation of Discovery last week, no one thing, but the sum of all those things together necessitates that we move out 6 or 7 weeks into the July window. Of course, you know, this is consistent with our overall approach to return to flight, which is that we're going to return to flight. We're not going to rush to flight. And we want it to be right. So we're doing what we need to do to ensure that. If I say any more, as I often say, I'll be repeating myself, so I'll stop. Bill, you may want to provide some more detail on some of that.
I think the only other factor that we would probably share is, as a result of those reviews, I think, and new data that we have on the reinforced carbon-carbon and the tile, and reviewing past films of some of the ice that has been shed from the LOX feed line on the external tank, that we may elect to go ahead and implement a heater in the LOX feed line bellows area, the forward one, which would also cause a little extra work and would put us out of the May-June timeframe. So I think the sum of all those things caused us to get together yesterday afternoon, and as a result of that, we're now going to re-vector here for the July 13th through July 31st launch window.
All right, let's take a few questions here. We'll start up front right here. Again, identify yourself.
Bob Zimmerman, UPI. From what I understand, you're thinking then of adding that heater to the external tank that's attached to Discovery at the bellows region. From what I understand, that heater is on later external tanks already. If that's, what was the reason for not implementing it right away on Discovery's external tank? Can you backtrack and give the background for why it wasn't there to begin with?
Well, to start out, you're exactly right. The third external tank, known as ET-119, is at the Michoud assembly facility right now. It's having that heater implemented because we could. Previously, the design engineering didn't exist for it, but also the data that we had on the fixes that we made surrounding those bellows, and you'll hear more detail from Wayne Hale and Bill Parsons later in the day. The design fix was called a drip lip, which prevented moisture from accumulating and reduced the volume of ice in that bellows area up to like 70%. So it was felt from the various analyses that we had done that perhaps ice, which had never been shown to be an issue before, was mitigated substantially. And so that was the reason for not pursuing that immediately. We have several kits that have now been manufactured and are available, and I think the prudent thing to do is to implement a field modification to the second tank, which would be ET-121, immediately, and that would be done in the vertical assembly building as they stack STS-121. And then after we complete more troubleshooting out on the launch pad and the main propulsion system, the external tank hydrogen engine cutoff sensors, I guess there's also some cycling and a repressurization valve in the hydrogen tank in the ET that we detected during tanking. All of those things would cause us to stay out at the launch pad longer. So in sequence, because we could, we have elected to go ahead and implement the feedline bellows heater at Michoud on tank 119. We'll do it on 121 at the Cape as expeditiously as we can in the VAB, and then concluding our troubleshooting at the launch pad, when we roll Discovery back, then we would implement the heater likely in the VAB there.
I also want to remind reporters also there'll be a live from NASA Johnson Space Center, some more in-depth and technical briefings from the Space Shuttle Program Manager Bill Parsons, Deputy Space Shuttle Program Manager Wayne Hale, and International Space Station Program Manager Bill Gerstenmaier. So a lot of those questions will also be answered then. All right, let's go with Tracy.
Tracy Watson, USA Today, for the administrator. I understand that there were some managers who were thinking about trying to delay the launch by a matter of days or a week or two rather than going to July. And I'm wondering if you can talk about why you decided to go with July.
Well, I can talk about why we decided to go with July. This was very much a team effort. I was at the reviews in question that I spoke of a few moments and that Bill talked about. Because, you know, I've publicly really given my pledge to learn everything I can learn about return to flight with the time we have remaining and the limitations on my capability. So I was at the reviews, but there were many voices, and in fact at the reviews there was no specific decision made. Reeds and his team spent a good fraction of yesterday assessing from out of those reviews what the logical conclusions would be, and so I would not honestly say that I didn't make this decision. The team came forward to me last night with a recommendation that we slip, and I've accepted that recommendation. So I think they were just all doing their job and doing it well, doing it exactly as we want them to do it. I couldn't be more pleased with the thoroughness that the whole process went through. So if you say some managers didn't want to move out of the window or wanted to move only a few days, well, you could count me among those managers. I want to launch as soon as we can. This brings almost a philosophical point up, which I'll share with you since I can. We constantly hear that you know, we tell ourselves, we try to tell ourselves, we try to tell others that, well, you know, schedule doesn't matter. We'll do the right thing. And I appreciate the philosophical intent behind those words, but schedule does matter. There are no human activities in which it's just okay to perform them whenever you like. Schedule matters. It shouldn't matter to the point of causing people to do dumb things or to take ill-advised actions, and that is where we want to get to. But schedule is one factor in the equation, and we want to launch Discovery when we can, because the completion of the International Space Station depends upon an expeditious launch schedule. We don't want to launch it sooner than we can. The conclusion out of the reviews that you spoke of, when all of the managers and all of the engineers had their say, was that we had enough work remaining to do, that trying to go in May or early June just wasn't the smartest thing. Am I being responsive to your? Okay, thanks, Tracy.
Let's go right here in the middle.
As a follow-up, Bridget Lingman, Cox Broadcasting, how confident are you of that July 13th to 31st launch window, and how realistic is it that you can take care of those fuel tank concerns in that time frame?
I think I need to defer to Reeds on that.
I'd say that every time we have established a launch date, it's been on the best data that we have available, and sometimes that's hardware-driven. Sometimes it's driven by the analyses that we must perform. I think since we first established a baseline launch date back in June of 2003, we've adjusted it now a half a dozen times, and each and every time it's been based on new data And we are going to continue to be milestone-driven on our approach to return to flight. In terms of handicapping it, I can't tell you, quite frankly. The troubleshooting that we need to do at the launch pad, they're still working on the various fault trees that they need to run to ground. This issue with 2 out of 4 hydrogen fuel tank engine cutoff sensors. There were also some other out-of-family events that occurred during the fueling of the tank, where the hydrogen tank repressurized probably twice as many times as we've seen in past tanking evolutions. But I think it really points to the wisdom of continuing to work on vehicle processing, launch processing, because quite frankly, we had not been to that launch pad since October 2002, hadn't conducted a fueling operation. There are a number of things that we'll need to do out at the launch pad here in the coming weeks, likely as not, that it's important to go do. That may include loading hypergolic propellants. It may include doing hot fire of the orbiter's auxiliary power units and the solid rocket booster hydraulic power units. Those cannot be done other than at the launch pad. And certainly some of the troubleshooting may include having to flow propellants again, not only through all the ground infrastructure, but also back into the tank. So all those things point to the fact that we need to continue pressing on, and as we gather more data, we'll retire more problems. We may identify more problems, but we'll solve each and every one in sequence.
All right, let's come up front, Brian.
Brian Berger with Space News and Space.com. This question's for Mike. You pledged to undertake a review of the Hubble Space Telescope servicing mission once NASA completes return to flight. With this decision, you've lost 2 months on the front end. Is a review of Hubble still tied to completion of return to flight?
That's a very good question, Brian. Thank you. The answer is we're going to start early on reviewing the Hubble decision. I've spoken yesterday in anticipation of this issue with key congressional stakeholders, and what we will be doing, and unfortunately for some of our troops, this is the announcement of this the first time, but you asked, what we're going to be doing is getting the shuttle Mission 4 servicing folks at Goddard started on the work that they would have to do if a servicing flight can yet be done. This is because, as I know everyone on this press conference is aware, we have legislation from the, we have appropriations legislation in our FY05 bill directing us to spend money toward Hubble servicing. If we delay much more, we first of all put the capability of doing that servicing at some risk, and also we're at risk of noncompliance. We could go back, of course, to the Congress and seek relief, but it seems most sensible to begin, I'll use the phrase betting on the come. Not that I actually spend much time in Las Vegas, but it's an apt phrase. We're going to bet on the come a little bit that we can do the servicing mission and get folks at Goddard started on doing what they would have to do to enable that. Now, there are substantive technical questions remaining on the shuttle end of things that we simply can't answer until we return to flight. So there is the issue of possibly we would be expending some money that would ultimately not serve our purpose. So that's why it's a bet. On the other hand, if we followed the explicit direction of the legislation and worked on the robotic servicing mission for Hubble, every review team that has studied that has concluded that the robotic servicing mission is just not feasible within the time and the money that we have to allow for it. So that's off the table. So if we're going to rule that off the table, then we need to consider what we can do that would be useful in advancing the Hubble servicing goal, and this is it.
Do we have another follow-up from Brian?
My follow-up is for Bill. Bill, at the same time you're preparing for return to flight, do you have the engineering staff to support the review of the SM4 decision without taking your eye off the return to flight ball?
Well, I think first things first, the vision for space exploration talks explicitly about return to flight, assembly of International Space Station. That's what we're focused on here immediately, is return to flight. I think what the administrator has just shared with you is there's a lot of work that can be done in parallel here. And the crew out there at Goddard is well equipped to go ahead and commence this effort. We have flown 4 missions to Hubble before, as you know, and so there's a body of engineering and expertise that's still resident within the Space Shuttle program that we can avail ourselves to. So I don't view these as being in conflict. Return to flight, and by that I don't mean simply STS-114, but STS-114, STS-121, and then resolving whatever issues may arrive from those test missions are prerequisites, obviously. But there's no reason why some of this work cannot be done in parallel and should not be done in parallel.
Yeah, and to Reed's point, the reason I characterized it as betting on the come was specifically because we're not going to allow any of the SM4 work on Hubble to interfere with return to flight. I mean, that is a guarantee. But the folks out at Goddard who are needed to prosecute that effort are not in a serious path on return to flight. So, yeah. Just to be clear.
I think Guy has his hand up.
Guy Goulian of the Washington Post. In pushing back the STS-114 flight for a couple of months, in adding a Hubble flight, you still have not moved the retirement of the shuttle beyond 2010. Do you see that in the coming years, and that you're going to be strapped to conduct the number of flights you need to assemble the space station? Will you push the deadline outward?
The President, the space policy that we have is very firm that the shuttle will retire in 2010. So in assembling the space station, what remains for us to do, if we cannot complete the requisite number of shuttle flights by that time, should that occur, is to be creative in looking for other means by which some of that hardware might be put on orbit. We may not be able to make the exact completion date we desire, but we will complete it. I've said this in other fora, to include the U.S. Congress for my confirmation hearings. We are recovering from a major accident here, a huge national tragedy. Putting people into space is still not so routine that we can do it blithely. Every mission where we decide to launch people into space with the level of the technology we possess today is a big deal. We take it seriously. Other considerations, such as exactly in what sequence and in what dates that we are able to assemble the International Space Station, have to come behind making sure that when we launch people, we're taking it seriously. That's what you're hearing from us. Part of the problem, I think, is that as the decades have gone by, when we have been able to do human space flight, we've come to accept it as more or less routine. From an engineering point of view, it isn't. When some of us, some of you weren't even born, but when some of us were, say, 12 years old, and we launched Alan Shepard, everybody knew that Al was risking his life. That's why they were heroes. The people who get on the shuttle today and fly it, or who have flown it, such as my compatriot here, are every bit as much heroes as Al Shepard, Gus Grissom, John Glenn on his first flight. They're every bit as bold, courageous, and risk-taking as were the astronauts of a generation or 2 generations ago. We may have lost sight of that fact, but the fact hasn't changed. So this is a big deal. We're treating it as a big deal. Assembly sequences, ways and means to get that done are a big deal too, but not as big. So that's how I view it. Thank you.
Go ahead, okay.
schwere Discovery muss noch 2 Monate länger am Boden bleiben, denn die Weltraumbehörde NASA hat ihren für Mitte Mai geplanten Start auf Juli verschoben. Die Entscheidung fiel nach Tests am Außentank. Dabei hatten die Ingenieure festgestellt, dass sich durch den verflüssigten Treibstoff im Tank an der Außenwand Eisstücke bilden können. Diese Stücke könnten beim Start abbrechen und die Kacheln des Hitzeschildes der Raumfähre beschädigen. Jetzt soll der Einbau einer zusätzlichen Heizung die Eisbildung verhindern.
Thanks everybody for coming out tonight. I'd like to introduce my crew. I know most of you know the crew, but I'd like to introduce them once more. Starting from your right, we have Andy Thomas, who's our MS3. He's our IV and our inspection lead. Charlie Camarda is our MS5. He's one of our inspection gurus and logistics transfer crew members. Steve Robinson is our MS2 flight engineer and one of our EVA crew members. Wendy Lawrence is our logistics lead and our space station arm operator. And Jim Kelly is our pilot. He's arm operator for our space station arm and the shuttle. And I'm sorry to say that our MS1 crew member, Soichi Noguchi, isn't here right now, but he will be here in about 30 minutes. I was trying to decide if we should wait for him for the statement, but you're welcome to stay here. When he arrives, he's too far behind us because we did hear him on the radio, but he's about 30 minutes or so out, so you're welcome to stay. I do want to say that this is a great event for our crew. We love coming down here for the Terminal Countdown Demonstration Test, or a TCDT as we call it. We're going to get some great training for the 3 days that we're here. Our training revolves around emergency procedures, understanding what is taking place in the launch countdown, the procedures and the operations. We'll have classes on that. And we'll also, the highlight is Wednesday morning we'll be strapping in, just like we'll be doing on launch day, and going through the procedures with the launch control team, just the way we'll be doing it on launch day. This is great practice for them as well as it is for us. I did want to say something about the launch, as you know, has been postponed to July. We are hoping that you are not too disappointed with this. I know we were marching along towards the March launch date, but I truly believe that we've made the right decision in going to July. It's going to give the teams more time to prepare. And like anything in life, the longer you prepare for something, the better it is going to be. And we want this mission to be very, very successful. Everything that we do, we want to be very successful, and this is going to give us more time to make sure that we haven't missed anything and to make sure that the objectives that we want to attain on this mission are completed as safely and successfully as possible. So thank you for your patience. We are certainly going to be patient in this and take the remaining time to make sure that we're doing the best that we can. We know that we're going to be seeing you on Tuesday morning, so we welcome you to come out, and we'll be happy to answer your questions. So have a good night.
Good morning, everyone, and we'd like to welcome the STS-114 crew to this opportunity with news media to talk a little bit about their flight and answer some questions. So I'll turn the microphone over now to our commander for STS-114, Eileen Collins.
Thank you and good morning. Thanks for coming out. We're down here training. This morning we had a chance to drive around our space shuttle out here on the launch pad, our beloved space shuttle, which we're very much looking forward to flying. Whenever we're ready to go, the crew's going to be ready to go. And it's pretty exciting for us to be at Kennedy Space Center. What I'd like to do is have each one of the crew members introduce themselves again and say a few words about what they're doing on the flight. And we'll start with Andy.
Good morning, my name is Andrew Thomas. I'm MS3 on this flight, and my primary responsibilities are going to be running the arm and doing the boom inspections on flight day 2, and then supporting the EVAs as the IV crew member on the EVAs later in the flight.
Good morning, I'm Wendy Lawrence, MS4. I'm flying the space station robotic arm. for NPLM and ESP2 installation, and also in support of the EVAs. I'm in charge of all the transfer operations.
Howdy, I'm Steve Robinson, flight engineer and very fortunate spacewalk guy.
Charlie Kamada, MS5. I'll be doing boom ops with Andy in Vegas, transfer with Wendy, and rendezvous.
Good morning, Soichi Noguchi from JAXA, EV1, MS1, happy to be here.
Hi, Jim Kelly, I'm the pilot. I do what Eileen tells me to do.
Yeah, Jim Kelly is our also arm operator for us, and does traditional pilot duties, and he'll be flying on orbit, and he's very humble, so I always have to kind of fill in for what he's doing, but he's a great crew member as well as the rest of us. Here we've got a crew that's been working very, very hard since October of 2003 when we officially were assigned to this flight. We are at a point where we've been training pretty hard. We're at a point where we're ready to fly the mission. The 10 weeks that we have from here to launch, 9 or 10 weeks, we're going to use that time to make ourselves even better. We can always practice more. We can always fill in the gaps. We can always anticipate more contingencies that could happen on the flight. We're going to be even more prepared by the time we fly. And when the Space Shuttle Orbiter is ready to go, we're going to be ready to go. And we're pretty excited about that. Before I open up for questions, I also want to say thank you to the workers down here at Kennedy Space Center who have been working very, very hard to make both Discovery and Atlantis ready to fly at the appointed times. Because of the delay, some of those folks are going to be able to get a well-deserved break. They'll be able to start getting weekends off, and we'll still have a time to do more work that I'd be happy to try to answer some questions about if you have any questions on what's going to be happening this week or what's going to be happening from here to July. So with that, I'm going to hand the mic off and we'll do some questions.
And what we'd like to do, because of the number of media here, please just ask one question and just cover a single topic without having a question within the question, and that'll let as many as we can get a question in. All right, we're going to start here in the first with Marcia Dunn from Associated Press, and each please give your name and affiliation when it's your turn at the microphone. Marcia?
Marcia Dunn, Associated Press. For Commander Collins or anyone else on the crew, NASA could spend forever working on the tank to prevent debris from coming off, and at what point do you say that it's safe enough to go with what you've got, you fly with what you've got, and will you be at that point, do you think, in July?
Well, I think we have to be at the point where we have enough information where we can answer that question. There's a lot of analysis and work going on in the integrated environment, the flight environment through first stage and really up to main engine cutoff. Is to what are the hazards, do we really understand them? We need to take things that are in an unacceptable risk category and get them down to either an accepted risk or a point where we understand them enough that we're safe to go fly and we understand the environment. So I guess my answer to that question would be we cannot fly with anything defined as an unacceptable risk. And we are not at the point we can say that's definitely not the case. So at that point, when we get out of the unacceptable risk, we'll say we're ready to fly.
Yes, Stefano Godan, New York Times and Time Magazine. Dr. Kamada, I was wondering, as a thermal expert, do you think these 2 extra months will be enough for you to have a really very best external tank that you can possibly have?
I think from the external tank standpoint, I think we're there. I think the changes they've made. We feel confident that the debris that's going to come off the tank will be small enough that it will not that it will be in the acceptable risk category, like Eileen said. And I think what the folks are doing right now is they're doing the analysis to come up with those numbers, to get an idea, get our hands around what the risk really is. And I think we're taking this extra time to do that. And I think once those numbers are in and we feel comfortable, we'll be ready to fly.
Commander Crew, Dan Levitin, WGXT Jacksonville, Florida. The recurring theme on the people we've talked to here at the Space Center seems to be pride, goosebumps on the arms, tears in the eyes. Can you talk about the pride you're feeling on this mission and how important it is?
But, you know, from the position that we stand in as crew members, you really get a very, very deep understanding of the work that the people are doing, because we have contact with people all around Kennedy Space Center, Johnson Space Center. They believe in the space program they believe that space exploration is what we need to be doing, not only as a country, but as a planet, and bringing the international community together. And people are, you work long hours and you dedicate your life to something like this, and you believe in what you're doing, and we share that pride with them. And I just can't say enough about how much I appreciate the dedication and the people trying to make themselves smarter and looking at things that we haven't looked at before. We just send our thanks out to all of you, and we're part of a team. We really want to emphasize the teamwork, and our role is to take this space shuttle up into space and do the mission, do it as safely and as successfully as we can, and bring the orbiter back to flight again another day, and we'll do that.
This is John Kelly from Florida Today for either Charlie or either one of the spacewalkers. With the 2 extra months, I'm curious whether or not you guys think any of these tile repair techniques, either for the DTO or that you might use in an emergency, might mature enough and change what you intend to do on the actual flight?
Okay, we'll send that to our EV1 Suichi.
Yeah, question about the tire repair. Yes, we're going to use these 2 months wisely. We will have extra underwater training, plus we might have some time to look at the other possible repair techniques like overlay, and we just use the time wisely.
No. Okay, we can go on to the next.
日本テレビの小林と申します。野口宇宙飛行士にお伺いします。打ち上げ予定日まで数週間というところで今回延期の決定がなされたわけですが、野口さんご自身どのようなお気持ちでその決定を受け止められたのでしょうか。
はい、延期は非常に妥当な判断だと思います。2ヶ月間の余裕が与えられたので、この期間を有効に使って、訓練をさらに高めていきたいと思っています。
You like that? Very good. That's what Steve would have said too.
I agree. David Waters from Central Florida News 13. Now, I'd asked all of you some months ago if you were going to bring anything up in honor of the Columbia crew, and at that time you told us yes. Now I'm sure you've nailed down the specifics. If you can kind of tell us what you're going to bring up with you specifically, and maybe characterize some of the conversations you've had with the Columbia families.
Okay, yes, we do have a plan, and we were going to wait until a little bit later to announce this because we thought it'd be better to do it close to the flight. I know that we're asked a lot about what we're going to be doing for Columbia. Let me just say that we have a plan. On one of the days on the flight, we'll do a downlink in remembrance of the crew and their mission and their friends and family. We will be taking some things on orbit. I will say that we have a picture of the crew that we've had packed for a while, and we will display that on the mission, so we will be remembering them every day whether we have the picture or not, but that's a visible reminder to us, something that we have in our offices and our homes that we want to carry on into space with us, because we'll be completing a mission that they were doing, which is to explore space, get the International Space Station built, and plan for future exploration of the Moon and Mars. And that's the message that we want to get out as we remember our Columbia crew, because that's what they believed in and that's what we believe in.
Hello, Tarek Malik from Space.com. My question is for Commander Collins. After 2 years of training, here you are at the pad. Your vehicle is there. You know, what are basically what is new to you? You know, being able to train now and tomorrow to prepare for your final countdown launch.
Well, we've come a long ways forward by getting our space shuttle and stack out here to the launch pad. It's still very motivational for us. We're that much closer to the launch, and just coming out here and doing the training, and we're meeting our closeout crew, which are the people that will be strapping us in on launch day. We're going to be doing emergency procedures training. We'll be meeting the fire rescue technicians, the people that would, if we ever came to that, would be helping us in the event of a potential emergency. This is the stuff that we're doing today, but just, I would say, the feeling of being out here with our space shuttle, regardless of what our launch date is, we know we're that much closer to launch. We know our mission is going to happen, and it's going to be a great mission. So
Hi, my name is Bill McGinty. I'm with WTSP TV in Tampa, Florida. My question is for any of the astronauts that have flown before, and for the millions of people who can only imagine what it is like to take a space shuttle into space and land it again through the atmosphere, would you please describe what it is like on liftoff inside the space shuttle, taking it up through the atmosphere and then bringing it back?
Okay, thanks. Yeah, I'll try to do that briefly. You know, I've been on one space flight myself, STS-114, and for me, the ride uphill is a lot like a roller coaster. You once a solid rocket booster's light and you're leaving the pad, there's a whole lot of shake, rattle, and roll going on for the first couple of minutes there. It's hard to see the displays because everything's rocking around quite a bit, and as you go through maximum aerodynamic pressure, so it's really a neat ticket ride going uphill through those first 2 minutes. And after the solid rocket boosters come off, about 2 minutes later, you get kind of the explosive bolts that come off, and you can kind of see that flash in front of you. And from there, it gets very smooth for the other 6.5 minutes until the main engine cut off. And from there, it gets smooth. It starts getting darker outside the window. You do a roll the heads up, and really the whole time it feels like you're just getting heavier and heavier because you go from about 1.1, 1.2 Gs. You feel like you weigh a little bit more than you do down here on Earth when the solid rocket boosters come off. And then by the end of it, you weigh 3 times your normal amount. You're pressed back against the seat, and then boom, in just an instant, all that pressure goes away, and then you're kind of floating in your seat. And then there's a flurry of activity as Andy comes up from the mid-deck to do the external photos. You get that first real time where you can look out the window and see the view of the Earth in front of you, and it's just absolutely gorgeous. It's a shortcut to the end of the mission, then coming back down. My last commander, Jim Weatherby, described it as kind of a runaway train, and that's what it feels like. As you start coming back in the atmosphere, as a lot of you saw from the Columbia video, you can see the plasma going over the windows. You're lower and faster than you are any other time in the mission, so when it was rolled over to my side, it was at nighttime when I came back, watching the lights just zoom by underneath you, faster than I've ever seen anything move. It's just fantastic. And then obviously coming back down in, you get a little bit of a burble coming through the Mach, and coming around the hack, you're feeling G's for the first time in 2 weeks. That feels a little bit weird. We had some clouds coming down, so the first time you see the runway, you're really excited that it's there, and then obviously everything comes to a halt. And one other thing I'd like to say about what we always say about entry is the slower you go, the faster it gets in the cockpit. You know, when you're going Mach 25, not much is happening. When you get down to landing speed, there's a whole lot of things going on in the cockpit, and so it's a very exciting time. And obviously you come to wheel stop and you breathe that big sigh of relief, but you still have a job to do until you turn the vehicle over to the great people here at Kennedy Space Center. So it's a great train ride all the way back down to the ground.
Yeah, we're getting excited just listening to him.
My name is Uchida from NHK Japan Broadcasting. Excuse me, it's another question in Japanese. すみません、あとローンチまでの間なんですけども、さっきも有効に時間を使いなとおっしゃいましたが、タイルのその修復技術も含めてどう具体的に使われるのか、どこに重点を置いて使っていかれるのかというのをぜひ伺いたいと思います。で、返事は英語でもお願いしますということです。よろしくお願いします。
Okay, the question was how do we use the next 2 months for the EVA training, and the answer is yes. We're going to use these 2 months wisely for the EVA training. We have actually 3 or 4 NVLs runs, the underwater training, and also we have a lot of desktop type session amongst the crew, instructors, and the flight controllers to make sure that we are all in sync for what we actually do on orbit. And also probably have some time to try the new techniques like overlay and some other new device for the imaging devices, imaging as well. And the answer in Japanese is really short. Yeah. 2ヶ月間の間にEVA に関してはまずインストラクターとクルーとフライトコントローラー等のまず教師を良くするための時間を持ちたいと思っています。それに加えて新しい補修に関するテクニック等も見る時間があるかなと期待しています。Do you have Steve? Yeah. He's honorary Japanese, so he understands everything.
Okay. Alan Boyle with MSNBC. I wanted to ask, as you get into the final hours of the countdown and the liftoff, what sorts of things are you going to be watching for that have changed since the Columbia tragedy that might lead you to abort a mission early, or to pull a plug, or to make some sort of change? How do you respond to an emergency?
Well, you know, just off the top of my head, I think there's very few things that have
changed since 107 launched, the Columbia mission. Our launch commit criteria is basically the same. The things that we look at, the instrumentation, the systems. I do know that we have cameras out here that are basically all up and down the Space Coast, close to and far away. There's, I don't remember how many, but I'm talking dozens of cameras, and I know that some of them have been added to the launch commit criteria, but otherwise I think our launch countdown is going to be pretty much the same.
Dan Villa, West TV for Dr. Camarda. Do you think you'll be able over the next 6 weeks to 2 months to develop any additional confidence in the repair techniques that you're taking up with you? Confidence in terms of flying home if you need to with those, or is it the actual work in orbit that you will do that you need to develop that confidence?
I guess I would hope so. That's really a question for the program office. We have other concepts out there, like the overlay concept, like the plug concept, and like the small area repair concept. That the small area repair concept is being looked at in the R&D community, and just like the folks that deliver the IR camera, a lot of these folks are doing an excellent job. I think if we reprioritize maybe and we start putting some emphasis on some of these other concepts, I think we would be able to mature some of these concepts, like you've heard, like the overlay concept, and possibly the plug and the small area repair concepts. And we have these 2 months to do that. It's really up to the program office, and they're in charge of the funding and how they direct the funds to prioritize what they do next.
Randy Siegel, WSTU Radio. Andy, with you doing the boom and the examination, do you have great confidence in the ability of the boom to detect exactly what you need to detect should there be any problems with the tiles or the RCCs?
Yeah, I am confident. We've run a lot of simulations with the boom and the sensors on the boom, and they do provide a very high degree of resolution in their ability to examine the critical areas like the leading edge and the nose cone. So I'm confident that in the very, very unlikely event that we were to have some damage to those areas, that we'd be able to see it.
Kevin Oliver with WFTV. Given the recent debris analysis, do you feel that those of you that have flown before, were lucky in the past, making it up and back safely? And how much should you rely on luck for this mission?
You know, the work that's been going on over the past 2.5 years, we have learned a lot more about the environment that we fly in the space shuttle, the way the ET is built and designed, and changes that need to be made to it. You know, all I want to say is I want to look to the future. We will learn from the past. We have been going through photographs and data from past missions for what we have for the daylight hours, and I want to look to the future and say, what can we do better to make the space shuttle system safer? Not only what can we do, but how can we observe, like with cameras? As you know, this is going to be the most heavily photographed mission ever. This flight and the next flight with daylight launches, and that information will be looked at to determine, do we need to make any further changes to the external tank, or to, you know, anything that could cause debris from the space shuttle stack.
Yuki from Fuji TV. This question for Mr. Noguchi. Could you talk about TCDT a little bit, what you have done so far and what you're going to be doing today and tomorrow? 日本語でもお願いします。
Yeah, for TCDT, actually this is my first TCDT, the terminal countdown testing, and I was scheduled to do the TCDT a week before Columbia, and we missed it. So I was really glad that we come to this point of a training. And what we have done so far is that we have a lot of briefing from all the KC engineers and the managers. Plus, we did some kind of emergency egress training. The highlight so far is that we dropped the tank yesterday around the bushes behind you, and we are now the certified driver of the M113.
More answer in Japanese as well.
ターミナルカウントダウンは前回はコロンビア事故の1週間後に予定されていて、残念ながら私経験できなかったので、今回ここに来れたことを非常に楽しく嬉しく思ってます。で、まあ KC の人たちからいろいろなビークルの仕上がり具合等について聞く時間が非常に多いんですけれども、 昨日は例えばタンクに乗って緊急ダッシュの訓練をしたりですね、この後緊急ダッシュのバスケットに乗ったりするので、そういうここでしか味わえない訓練があるのが非常に楽しみです。
CBS Radio, good morning. I'm wondering, and this is for any of the crew members, with another delay, is there any point where you go into JSC in the morning for training or whatever, and you say, you know, I feel like I've kind of maxed out. We've done this before, and we're doing it again and again and again. And I'm wondering if the training ever gets old for you in that way, and you kind of say, I'm not sure that I can do anything.
We're going to give that question to Wendy.
Being an assigned crew member is the best job in the world. As you all know, that when we're not assigned to a crew, we have other technical assignments in the office, and sometimes those are not very glamorous jobs. You're involved in doing a lot of email, doing a lot of meeting support. So my crew member has often heard me say that there are no bad days on this training flow. But you do bring up a good point, particularly for the flight deck crew members. You want to peak right at the right time. It's just like an athlete preparing for the playoffs. You want to make sure that you're playing your best game when you go into the playoffs, and so they'll continue to do some simulations to maintain their performance at the peak level, and we'll continue to do the training. And for me personally, I felt that this training flow was very, very busy, working on a lot of issues associated with return to flight. So I'm actually looking forward to a little bit of a slower pace so I can actually spend a lot of time studying the procedures we're going to do during rendezvous, looking at my transfer plan, studying the space station robotic arm procedures that I have to execute.
And vacation.
My name is Hiraishi Kiriasahi. This is a question for Mr. Noguchi. 一月ほど前に野口さんはできるだけ早く宇宙へ行きたいとお話しされていましたけれども、たびたび延期が発表されていることについてのお気持ちを、焦りや不安はないのか、お気持ちをお聞かせください。
はい、焦りはないですね。やはり1ヶ月、2ヶ月と余裕ができたことで、むしろ自分がやりたかったトレーニングを追加できるということで、今は非常に余裕を持って当たってます。やはり非常に長いトレーニングになってますのでね、4年、足掛け5年近くなってますので、いかに最後まで平常心を保てるかというのがポイントだと思っています。
Okay, I'm told that you'd like to have a photo, and we'll set up for that. But before we do, I wanted to make a closing statement. Our thanks to I mentioned people here at Kennedy Space Center, but also Johnson Space Center and all the NASA centers around the country, and to the public. We want you to know that we are very motivated to fly this flight. We're going to make ourselves even better in this few extra weeks that have been added before we fly. We will fly our space shuttle someday, and we will fly this mission. That is something that we're very excited about, and we want you to hang with us, be patient. We know that we're doing the right thing, and we ask you to hang in there, the interest on the mission, and we'll keep you informed on the things that we have coming up and any changes that are going to be made, and that will be made, and I think there'll be some decisions made this week, and we'll get that to you as soon as we know. Thanks.
You take your shades off.
I don't know why you guys think sorry of that.
Thank you very much. That will conclude our opportunity. Thank you very much, Ollie.
All the way on the end, like something wrong.
We're now in the crew quarters for the breakfast, and we see Mission Specialist Wendy Lawrence and Jim Kelly with Soichi Noguchi. And our Commander Wendy Lawrence. Mission Specialist Andy Thomas. And pilot Jim Kelly with Charlie Camarda. And after breakfast, they'll be heading off to the suit-up room in preparation for leaving for the launch pad at 7:45 this morning. There will be a weather briefing for the commander, the pilot, and the flight engineer. And they are ready for this morning's countdown dress rehearsal. This is Space Shuttle Discovery at Launch Pad 39B as it stands now. The launch team is in place here in firing room 3, and the suit-up crew is ready in the astronaut quarters to help the astronauts suit up, and the white room crew will be entering shortly to prepare for the arrival of the astronauts, which is expected at about 8:15. At T-minus 3 hours and holding, this is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. The astronauts are finishing up breakfast and we'll be heading for suit up shortly. We're going to look now at some of the crew training activities that have been underway since they arrived. This activity we're going to look at occurred on Monday. Much of it involves the M113 Armored Personnel Carrier training that they use if they have to do an emergency escape from launch pad area. This is their initial briefing inside the Armored Personnel Carrier. And then they are given instructions on how to drive it. This activity is customary before every flight with every crew.
Okay. Ready?
And they actually have a chance to learn how to drive it, actually do that.
Yes, sir. It'll only work once you turn some master.
This normally operates at a speed around 30 miles an hour. This is some of the flight packs, crew packs that are part of their suits that they're given some discussion with the suit techs and the crews that pack these for them. The shuttle training aircraft is flown by the commander and pilot. This was on Monday night, Eileen Collins and Jim Kelly. Shuttle training aircraft is a Grumman Gulfstream jet that can be configured to fly exactly as the Space Shuttle does. And they are able to practice and hone their landing skills during all of their training activities. And they will do this once again when they return for launch to ensure that their landing skills are honed to the sharpest extent possible so that they could do that if there was a return to launch site. This is the slide wire basket system and the crew bunker that they can use if they should use baskets to escape from the pad in the event of emergency. They're trained up on the fixed service structure as well on how to deploy those slide wire baskets after they get in.
It depends on the slide wire.
This is one of those baskets going down to the bunker area. They move down the slide wire at a speed of 55 miles an hour. Then the crew gets out quickly and heads for the bunker for protection. All that activity on Monday in preparation for the launch. It's all part of the terminal countdown demonstration test activities where the crew receives training on launch pad safety systems and procedures, and also has a chance to board the Space Shuttle and go through a complete countdown as if it were launch day. Next activity coming up in about 5 minutes, where we expect the astronauts to be in the suit-up room, donning their orange flight suits so that they can be on board Discovery for the last 3 hours of this countdown dress rehearsal. At T-minus 3 hours and holding, this is Shuttle Launch Control. We're now in the suit-up room where we see Commander Eileen Collins going through her suit-up activities in preparation for going to the pad shortly. That is pilot Jim Kelly, who will be having his helmet attached, and there'll be a pressurization check of the flight suit and the helmet. Mission Specialist Charlie Camarda, Mission Specialist number 5. Mission Specialist Wendy Lawrence. This is her 4th Space Shuttle flight. She has over 894 hours in space. Mission Specialist Andy Thomas. Mission Specialist Steve Robinson. This is his 3rd Space Shuttle flight. Again, Andy Thomas. Going across the room now, our commander once again, Eileen Collins. And here comes the STS-114 flight crew, leaving the suit-up room, headed down the hall to the elevator from the astronaut quarters on the 4th floor of the operations and checkout building. They're entering the elevator. Out front is the astronaut, the Astrovan, as it's called, crew transfer van, and it will take the astronauts out to launch pad 39B at the end of the Atlantic Ocean. It's about a 20-minute ride from the astronaut quarters out to pad 39B. And here they come. We were greeted by Kennedy Space Center employees and press contingent. Weather here at the moment is still acceptable for crew to board Discovery, although at T0 today at 11 o'clock there is expected it would be an 80% chance of launch weather criteria violation if this were actually launch day, primarily due to low cloudiness and thunderstorms in the Kennedy Space Center Cape Canaveral vicinity. And there they go. No COLAs today, or collision avoidance quotients, if this were launch day. This involves anything the space shuttle might encounter on its way into orbit. This is the pad ramp at pad 39B. And we'll see the crawler transporter sitting on the crawlerway that brought Discovery out to the launch pad. The launch director and flight director are now talking and confirm that we have a good test going so far. They're approaching the gate now at the pad. Astronauts getting off the crew transfer van, heading into the elevator to take them up to the orbiter access arm. Crew entering the elevators. We're looking at this through one of the operational TV cameras at the pad. Most of the astronauts are on board Discovery. We should hear them communicating with the launch team here in the firing room and with Houston Flight. And here they are, arriving to board the crew, shaking hands with some of the United Space Alliance technicians. And they'll be greeted by the suit-up crew in the White Room, or the crew ingress team, astronaut support person as well in the cockpit. And they may all remain outside for a while, since they'll be boarding one at a time. There's not a lot of room in the White Room. And the ingress technician will give them some help with their flight suits and their helmets. Eileen Collins now going in through the mid-deck and up to the flight deck. She'll be sitting in the left front seat. In this picture, we can't see the windows of Discovery, but we can see the left and right seats and the flight computers and the primary switches in the cockpit. Here comes Eileen. Out of the final hold in 10 seconds.
Time clock will resume on my mark. 3, 2, 1, mark. T-minus 9 minutes and counting. TLS auto sequencer has been initiated.
The computer here in the firing room is now in control entirely of the countdown up until it hands off to Discovery's computers at T-minus 31 seconds. The ground launch sequencer will be checking over 1,000 parameters on board Discovery during this final 9 minutes and will not hand off to Discovery if there is anything the computer sees is not configured properly for flight or could be a problem. After that, Discovery's computers will continue with the countdown.
PLT OTC, SIM connect essential buses to fuel cells.
OTC, PLT, simulated complete.
TLS is go for simulated OAA retract.
And again, we're not retracting the orbiter access arm today. But we can see that the ground launch sequencer has sent those commands. And we'll do a simulated pre-start of the auxiliary power units. It's coming up in about another 45 seconds. But electrically, we can see that those signals have been sent.
PLT OTC SIM perform APU pre-start.
OTC, PLT, I copy. Simulated steps are complete, and I show 1 actual step high main pump pressure 3 to low. I will accomplish those now.
Yep.
T-minus 6 minutes and counting.
OTC, PLT, APU pre-start simulated and actual is complete.
Copy that.
T-minus 5 minutes.
TLS is go for simulated orbiter APU start.
PLT OTC SIM APU start.
Copy, I will sim, and I've got 2 actual steps which I will complete for the APU start.
Copy. CDR OTC reconfigure heaters.
CDR, that can work. OTC, PLT, APU start is complete, simulated, and actual, and we have 3 simulated good APUs.
Copy all. Thank you.
OTC, CDR, heater reconfigure complete.
Copy.
GLS is go for per sequence 4.
T-minus 3 minutes.
GLS is go for simulated ET LO2 pressurization.
ELT OTC, clear caution warning memory, verify no unexpected errors.
OTC, PLT, cautionary memory cleared, no unexpected errors.
Copy. And GLS indicates NTD hold switch on, countdown clock will hold at T-minus 1 minute 57 seconds. And for all personnel, that is a planned activation of our hold switch, and we'll exercise that at 1:57 as indicated.
Discovery OTC, close and lock visors and initiate O2 flow.
Discovery copy, that's in work.
And countdown clock is holding at T-minus 1 minute 57 seconds due to NTD hold switch. Okay, and for all personnel, we have exercised the switch, functioning normally as expected. And with that, we are going to resume the clock here momentarily. And GLS, are you reset on your end? GLS is ready. Okay, and you can resume the clock on your mark, GLS. GLS copies. 3, 2, 1, mark.
So check to assure that NASA Test Director Jeff Spaulding could stop the countdown, overriding the ground launch sequencer should that be necessary.
One minute, 30 seconds.
External tank, liquid hydrogen tank being pressurized.
One minute.
Solid rocket booster joint heaters are being deactivated at this time, as they would an account. Standing by for the handoff from the ground launch sequencer to Space Shuttle Discovery's onboard computers. T-minus 31 seconds, and the handoff has occurred. Auto sequence now in work.
20. 15.
T-minus 10, 9, 8, 7, 6, 5.
And we have a cutoff.
We have a cutoff at T-minus 4.
GLS taping is in progress. PFS is 101. PAS is 101. LDB is 1.
NTD perform RSLS support. GLS taping is in progress.
Copy, and attention all personnel. An RSLS abort has occurred. All personnel turn to the RSLS abort sequence on page 456. And CDR, perform BFS taping on panel 06. Take GPC, mode 5.
Normally this would...
Take GPC, mode 5, switch to halt.
CDR copied in. BFS is in halt.
So I mean the onboard computers have seen something during the main engine firing prior to liftoff that means the clock, countdown clock was held. So we have simulated a main engine cutoff at T-4.
T-Lock verified. Copy, thank you. And MPL also fire detector status, please.
And no fire detectors are tripped. And heat shield water is on SIM.
Copy. NGLS fire detector status also, please. SIM none tripped. Copy. And PLT, can you verify AP shutdown complete?
Verify. AP shutdown is simulated complete.
Copy, thank you. And GLS, can you verify primary safe and complete and ready for transition? That's affirmed. Copy that. DLHY, report leak detector status.
DLHY verifies leak detector status.
Copy. And CPOP, can you verify?
We'll give you 48, sir.
Very good. CPSS, verify OAA.
Right now the launch team is going through the procedure to safe the launch vehicle, assuming that a main engine cutoff had occurred. We're demonstrating our capability to save the vehicle using all of the systems on the shuttle. Preliminary safing now is reported to be complete.
And this is the NTDM page 487, and we will proceed directly with the board safety checks. ISL verifying substep 1. ISL verifies 1. DPS 2.
And at this point, the launch team would be looking at the ground launch sequence of computers of Discovery to determine what it was that Discovery saw that cut off the count after the main engine ignition had occurred. And at this point, the initial safing of the vehicle has occurred successfully, simulated. And that essentially concludes the test for today. From the standpoint of the launch vehicle systems, we have been able to verify all the systems on board Discovery have operated as planned.
OOS-22. CBRS-23.
And we'll be troubleshooting a comm problem with the range, and of course weather we couldn't do anything about. The crew will remain on board Discovery for about the next half hour as we complete second part of launch vehicle safing, and then there will be a debriefing of the launch team and the astronauts by Launch Director Mike Leinbach. At that point, the astronauts will then go through a simulated emergency egress from Discovery, leaving the flight deck as quickly as possible and heading for the slide wire baskets. We're going to look now at a tape of some of Discovery's processing in the hangar at the Orbiter Processing Facility, beginning actually very early on in 2004. This is the left orbital maneuvering system pod being installed. This was back on April 24th of last year. This is some of the payload bay wiring electrical work that was done, and installation of some of the sensors. This is actually sensor installation in the wing's leading edge.
Work 963. Can you tolerate downless data loss?
Yes, we can. And 986 is complete.
Copy 986.
This is arrival of the last of the 3 main engines back on October 6th. It was taken to the main engine maintenance facility where it was unpacked and prepared for installation. And the shipping container removed from around the entire engine. And it's being taken into the orbiter main engine maintenance shop for final preparation.
No VCC, OTC. No VCC, go. Yeah, for your hatch cycle and your torque adjustment, what's your status, sir?
I'm ready to support.
Okay. When you're ready, you've got to go on hatch closer.
Copy that, and I'll re-verify that we do have portable below 2 meters, and I'll go to 142.
See that. ASM OTC, copy.
The main engine is transported over to the orbiter processing facility on the lift that you saw and inserted into the aft of the orbiter.
Hatch cycle, you could go to 140.
And the transporter backed away. Basically just a very large forklift with a special handling fixture. This is the remote manipulator arm, the mechanical arm, being prepared for installation. This is part of the Canadian contribution to the Space Shuttle program, both in terms of the primary mechanical arm and the orbiter extension. This is the crew equipment interface test where the astronauts were actually on board Discovery in the hangar, had a chance to go onto the flight deck and look at some of the work going on in the payload bay and other parts of the orbiter. Here we see our Commander Eileen Collins through the window. Payload bay doors finally closed for flight on March 25th. And the doors being closed for one of the final major milestones in preparation for rollover to the vehicle assembly building. We're going to look now at some of the work that was done to prepare Discovery for its launch in the vehicle assembly building. That actually began with rolling over from its hangar. This shot is one of the aft skirts that was used. I had a little ceremony for that as part of return to flight. This aft skirt for the solid rocket booster was taken to the vehicle assembly building in preparation for stacking the solid rocket boosters. This was last summer during August when our solid rocket booster stacking activities began. Here's the actual segment now with the aft skirt attached, moving into the VAB transfer aisle. Rolling in the north VAB, north side, north transfer aisle door. This is one of the segments being stacked last November. See this segment being taken across the transfer aisle for lowering to the segment below. This is the actual mating and the technician doing the inspection as the joints come together. and the forward assembly, including the frustum with the parachutes and the equipment module with the avionics. Now lowered atop the solid rocket booster to complete the stacking of that booster. The solid rocket booster retrieval ships are towing in the external tank barge that has the external tank to be used during this mission, coming up the Banana River. The vehicle assembly building in the background, still looking nonetheless worse for wear from the hurricanes from last fall. The external tank offloaded from the barge, transported to the vehicle assembly building, into the transfer aisle where it will be lifted into a test cell. The external tank carries 525,000 gallons of propellant. A third of it is in the top, which is the liquid oxygen, and the bottom two-thirds is the liquid hydrogen. Here it's being taken across the transfer aisle and twin solid rocket booster stack. And that rollover of Discovery occurred on the night of March 29th this year. Moved on the orbiter transporter through the north access door of the vehicle assembly building in the transfer aisle. And the wheels are then retracted. They've actually were retracted prior to coming over to the vehicle assembly building for its movement on the transporter. It's then rotated to vertical for mating to the external tank solid rocket booster stack. The lift is underway to take it across the transom of the high bay so that it then can be lowered for mating to the external tank. And following the mating, there was an extensive test of the interfaces between the orbiter, the external tank, and the solid rocket boosters to verify that they were all working together. That's part of the shuttle interface test. This is Space Shuttle Discovery during its rollout from the vehicle assembly building. There's a lot of preparation that goes on in the vehicle assembly building prior to first motion to assure that there are no work platforms still extended that could strike the shuttle during first motion. Shuttle moves out to the pad about a mile an hour fully loaded atop the crawler transporter. Combined, the Space Shuttle Discovery on the mobile launcher platform with the crawler transporter weighs 17.5 million pounds. The crawlerway on which Discovery is moving is 130 feet wide, about the same as an 8-lane freeway, including the 50-foot wide median strip. Top layer of crawlerway consists of 8 inches of river gravel, which is atop 4 feet of crushed stone. And then there's another 1 foot of compact fill below that. Crawlers have been outfitted with new shoes or cleats, each of which weighs 2,100 pounds, and there are 57 of these cleats on the 8 belts of treads on the crawler. Once it's atop the pad, there's a laser system that allows the mobile launcher platform to be positioned within ½ an inch on the pad's launch pedestals. To prepare Discovery for return to flight has taken 3.3 million man-hours of work, 8,000 inspections, and 25 pieces of flight hardware have been replaced or added to the vehicle. We'll look now at some of the activities in the Space Station Processing Facility to prepare the STS-114 payloads for flight. Beginning first with moving the multi-purpose logistics module Raffaello to a test stand. That work set the stage for much of the processing that would follow. The human research facility was then prepared for placement into the test stand. And this process is done using the rack insertion device, which basically extends out and through the opening of the multi-purpose logistics module and to exactly the proper location where the rack can be installed. Next activity was the control moment gyro installation. This is the replacement gyro being transported up to replace one on the International Space Station that failed a couple of years ago.
OTC, OVCC, 212.
OVCC, OTC.
I've verified the hatch is latched and locked, and the mic.
The astronauts have a crew equipment interface test with all of the payloads that are taken up to the station.
Those are thermocouple.
This is part of the tile repair kit activities that will be going on orbit. This is actually inside the multi-purpose logistics module Raffaello. This being installed into the payload canister, the lightweight infrastructure into the canister for installation into the payload bay, multi-purpose equipment structure, carrying the control moment gyro. This is installed into the payload canister as Raffaello will be. And now the lift of Raffaello to follow. Payload canister there on the right. This is where the payloads are now, awaiting their installation at the pad. The date for the trip to the launch pad and payload installation has not been set based on the new July 13th launch date, but the payload processing is essentially complete.
It's always easy to forget giving this. Yeah, you do.
4, go for command. Teedrus.
Looks good, Eileen.
Discovery Houston, com check.
Houston, Discovery, we've got you loud and clear.
Same here, Eileen.
339. PSS looks good.
Guidance flight.
Displays.
Nav check. Good.
High. Difference between the onboard nav.
Zeros.
I could go ahead and do a metering override. Spec 55, item 38.
Valves are closed.
Discovery Houston, Eileen, GPS is showing you 40 miles high. At this time, we would like on spec 55 an item 38, please.
Copy that. Spec 55, item 38 is in work.
Good copy.
There.
Get ready.
All right.
Potentially uplinking or taking GPS. Going.
Agree.
Oh, we've seen this before. When we get tack-ins, see what happens. Okay, 1.5G, pass Mach 16. 6 again.
Inco flight.
Flight Inco.
It'll get us a test command when we hand.
Oh, wow, that's not good.
GPS fail. Okay.
GPS 2. GNC.
We won't be updating by taking GPS. Oh, probably not.
Due to a internal hardware problem, there's no action for the crew. It is not usable.
Copy.
We had a set of port mode.
Discovery Houston, our indications show a hardware failure in the GPS. We're going to consider it unusable.
And Houston, we copy the hardware fail on the GPS, and be advised IDP-2 had a momentary big X.
GPS copy.
And it's working normally now.
Okay, copy. Momentary big X on IDP-2, and it's working well now. We'll look at indications.
X55.
Flight GNC. Would you be inclined to consider
a little bit
on GPS 2, or could we even do that if we wanted to?
The flight, we probably cannot access that switch on panel A13.
Okay.
It has a down arrow, so that means
GPS receiver is not tracking any
sound, which means it
has an indication that it's got a...
Yeah.
We ask them if they can put eyes on the switch, and if we thought we wanted a power cycle, they can tell us whether they think they can get to it.
Flight Mach 12. All right, Eileen. Yeah.
Power cycle, we need a GNC on
set.
GPS would be go for that.
Okay, and GPS...
SF3.
Universal
work
at the MDM.
Universal at the MDM.
Eileen, let's do this Mach 12.
My distractor right there.
Exactly.
Auto and arc. No reset.
Agree. Okay.
So this takes out uplink command on this string.
Roger.
Pulse looks like
port mode.
Yes, we are, flight. No joy on the IR reset.
Fork to port mode procedure.
Discovery Houston, Eileen, your go for the port mode on string 3.
Final, let me know when we get some tracking.
Go for the port mode on string 3. Rolling.
Yeah, that'll be an item 16.
Flight prop. Go.
My final.
String 3.
I agree.
Confirms high energy.
So I am 20.
Left bank 60.
Yeah, I agree.
Pause.
Discovery Houston, Eileen, the following is a GCA for high energy. We would like left 60, 60 left.
Eileen, while you work that.
This is a GCA for high energy and 60 left.
Good copy.
See, Vegas, I am done.
Okay, I see you.
I'll fly until I have another action.
Okay. Inhibit drag.
CSS in the Royale.
Discovery Houston, inhibit drag.
We're inhibiting drag.
Hey, folks, we're going to need to get command back here. Guidance.
I agree, Vegas.
Copy.
Roll yaw CSS, commander is flying.
Okay. Inco, you need to think about the panel command.
60 left.
On Milo, right?
Your brake's moving. I agree. And
there's no joy in the port
repo
mode.
should work. We got all our FAs and APUs.
They want me to do power cycle. I'll hand over to you.
Maintain 60 left. Left 60.
Did UHF or about the...
Discovery is left 60.
Check rad flow.
Both loops, rad flow.
Thank you. Okay, with FF3 down, by the way, it's...
Standing down.
Okay, let me know.
Takes out IMU, AA, TACAN, MLS, and their data.
Echo, you ready? Panel command, right?
We'll go for command.
TACANs are in, and they're obviously bad.
Discovery Houston, ease your bank to left 45, 45 left. We're with you on Mila. We would like a panel command for commanding.
Goes
45 left in panel command.
Good copy.
Okay, signal strength dropped off. Hopefully we'll come back, and it's back. Check. They need commanding to send the
I think we're requiring a forward link.
sector on board. Do a com check for me.
Houston Discovery, com check.
Go for command, Mila.
And you're loud and clear.
He's riding a little low there.
Oh, I don't
And Discovery Houston, Eileen, maintain left 45, 45 left.
Good command on Mila flight.
Thank you.
Left 45. We need to go pitch CSS.
Yeah.
We're going to do that.
And I have a Delta State ready.
Okay, through Mach 7.
CSS all axes, we're going to send
Discovery
them a Delta
Houston,
State.
we would like CSS all axes, Delta State coming on board.
Edward, CSS all axes.
Guidance flight.
Go ahead, flight.
You have a go to send the nav Delta State.
Copy, go for Delta State.
Yeah.
CSS all selected, commander flying.
Thank you.
Hey, good setup, Vegas.
Maintain left 45.
Discovery Houston, maintain 45 left, left 45.
Left 45.
10 degrees past side. It came on board, waiting for their go for TACAN. I concur. That's a big update. Big
Holy.
I agree, so we'll start going to the needles. I would agree, especially the pit.
Like guidance nav is go. They can take TACAN. Transfer.
Second hour air.
Discovery Houston, you can terminate the GCA, center the needles, go auto, nav is go, take TACAN.
10 seconds to roll reversal. They can follow the needles.
Center the needles, go auto and take TACAN.
Good copy. 5 seconds to roll reversal.
Okay, Vegas.
And we're rolling right. Go ahead and fly this in CSS.
Okay, Mach 5, we're less than 2 Gs. Here comes
Very good.
Griffin 16.
Probe's coming out.
And I see numbers. You know, they didn't call it. Yeah, you're right.
Houston, would you like us to transfer the state vector to the BFS?
We concur.
I'm going to get a new one because we rolled.
DPS flight on FF3, we'll pick it up if we get a chance. Where would you like to pick it up?
Flight, there were no signs of short in the real-time data, but I don't think we warrant a...
Good control. Out, please.
So we would pick up in step 12 of the procedure. That's the only step we need. We could just call BFS spec 50
out.
Deselect.
I had to do another one because the second one zeroed it out.
I think that's a good call. We'll do that when we get cleaned up.
That's right, yeah.
Right one's out. Both probes
Okay,
are out.
Vegas, I see numbers.
We need the item 16.
And we are on energy.
Very
good. Quick drag back in as well, Steve.
Air data
looks good.
evaluating.
Thank you.
Oh, wait a minute.
We
Stand by.
shouldn't know that yet.
Happy with our configure, right?
Yes, sir.
String 1, okay.
Like guidance state vector transfers in.
Probes are good. Probes are out.
Air data 3 is gone with that. Data, Steve.
Discovery Houston, to finish you up on the FF3 procedure, one last action. We would like you to deselect AA3 in the backup only.
So deselect AA3 in the backup only.
Good copy.
Houston, understand you do not want a power cycle on FF3.
That is correct.
And air data looks good to me.
Critical. We could always try that for something else.
Flight, take air data to GNC.
And an F.
Hey, coming through.
Discovery Houston, take air data.
We're taking air data. We're rolling to the pointer.
Hey, Eileen, you ready for a little briefing?
Processing air data.
Roger that. For the summary.
Okay, we have nominal hydraulics.
So,
the only thing we're down is F, and that takes out our string 3 nav aids. The right auto lights are out also.
Good config.
GPS is not working for us, so
Happy.
Good cool.
have it. Coming onto the hack, you're going to expect winds out of the east.
Good config.
Up to 70 knots.
How we doing, Fido?
Landing 3-3.
We do have a small wind at
Expect
0 to 10. That's 6.
7 on head, 5 from the left.
overhead
Cast at
panel.
11,000.
One of the overhead panels, I think.
And Flight Eagle, we just lost main A04.
That'd be 014.
014, I agree. My light is
Nose wheel steering to 2.
So we think we've lost main A014.
Okay, we'll take it off. Nose wheel steering off.
We concur, Eileen, and at this time you can turn nose wheel steering to off.
Flight GNC, we can also...
I agree with that. Yep,
nose wheel steering is off.
Okay, that takes out 2 AAs.
So 2 AAs.
Okay, and we're almost...
Right, AA3 and AA1. I agree.
And Discovery Houston, Eileen, we recommend pitch CSS for 2 AAs down, and if you have time, you can deselect AA1 in both pass and the backup.
Houston, we are pitch CSS and we'll deselect AA1 in the pass and the backup.
Good copy.
Okay, that's item 10, I agree.
We're okay here on
item 30.
We got 2 and they're good.
I agree.
Fine AOA.
And we have 280.
I agree.
Good config.
Ladies with AOA backup.
Okay, switch to red out 2, please.
Coming back to you. How's your nose?
Down 2 air datas.
Okay, I told him to turn it off.
Down 2 MLSs.
The red out goes down 14.
Okay.
Yeah.
Advisories?
Flight, we saw good as a semi-repo. We have no advisories for the crew. We are pitch CSS, Commander.
Download RHC as expected with what you're doing.
I was CSS, but I think I just downloaded in Rollout.
You've got both.
Okay, we're 1.1.
And Discovery Houston, we see you on energy approaching the hack. No changes to weather. Your winds, slight increase in the crosswind, now at 8 from the left. You are nominal shoot deploy.
Flight Ecom, I need both Freon loops off. We're under 10.
Discovery copies, nominal shoot deploy, and we're CSS all axes.
Oh, Freon loops.
We concur with that.
Low.
And Discovery Houston, Eileen will take both Freon loops to off, please.
That's complete.
Eileen, you are 5 seconds from the hack. It'll be right. 4.
You're off light. No more action till post-landing.
Okay, here we go. Let's watch them roll on the hack.
Eileen, pick your wind out of the east at about 70 knots.
See that? That was a good call by the ground to turn Freon loop.
Yeah, no kidding.
It's about the easiest thing from freezing up.
Last thing on your weather brief was overcast 11,000. I agree, it's definitely an undercast beneath us now. Yeah. So, landing 7 on the head, 8 from the left. Across. Altimeter is not locked on. We're at the correct altitude, so that looks good. Okay. Have it at TAC in. TAC in, that's for the car confusion.
Red L2.
On regard. It's
It doesn't.
Can you see the commander's position when we're...
A little bit high in the hack.
Commander currently has 1 selected at the switch, but we're greened out to 2 flight.
Okay.
And we're down to MLS
They're going to
2 and red out.
right on at the 180, slightly high. Not even slightly high.
I copy.
On at the 180.
Discovery Houston, on at the 180. Be advised you will be rad alt 2 only.
Discovery copies.
Action on the exit T's.
No action flight on the exit T's.
Pre-fuel cells.
Needs to start a purge for us. If that's the case.
What's our...
Discover, would you like us to start a manual purge on all 3 fuel cells?
And that's not required, Vegas.
Our temperature cooling below...
The T's are all above 250. On at the 90.
Discovery Houston, on at the 90.
Discovery copies. Our cloud T, off scale low.
Yeah. Up here. Slowly. Okay, your single MLS is working. I agree. Coming through 50,000, just got an MLS update, Eileen.
Okay.
Eileen, remember, you will not have nose wheel.
Over.
See that. No nose wheel.
Okay, mine went yellow.
Coming down to 11,000 feet, should be breaking out, and I'm starting to see the runway.
And Discovery has runway in sight.
Pappy's on my side.
So,
Overlay is perfect, Pappy's are perfect.
Great.
Land, body flaps, trail.
We're good. Okay.
For the room, on glide slope, on set.
8,300 knots, Eileen. Crosswind from the left.
Copy.
Radar.
working.
Radar altimeter 2 looks pretty good right now. Feet, speed brake 18.
Good commanding flight. Thank you.
1,000 pre-flare.
Pre-flaring, I see the light.
1,000 max speed 310. 800, 7, 600, 500, 400.
Go down.
Coming. 100, 280. 100, 260, gears down.
Copy gear.
65, 40, 235, 20, 230, hold it off a little bit. 10, 220, 210, 205, 200, 195 will shoot. 190, 185, derotate.
Rotating.
At 1, 1.5, 1.5, 2. Out, auto load relief. Full braking. Full brakes, nozzle steering, you do not, full braking is not required.
No nozzle steering.
I didn't want the crew in evap.
I agree.
Steering with brakes.
I've got a delta.
Affected brake pressure. Affected with FF3, I agree. We're about 5,500 feet remaining, Eileen. 60 knots, shoots away. Knots. 5,000 feet remaining. I agree. Through 40, you can back off a little bit. Knots, 4,500 feet remaining.
Discovery, wheel stop.
Roger, wheel stop, Discovery. Nice job. Welcome back to the Cape. We have no immediate deltas for you. However, Eileen, we're going to call you into the evap out T low procedure. When you have it open, let me know. I have deltas.
Houston, we're there.
There, Eileen.
Want me to give him step 3?
Yes, start him in step 3.
Houston, ready for deltas on evap out T.
Okay, Eileen, we would like you to start in step 3. Proceed. We will have a delta to step 10 when you get there.
Buddy, come, I can give you.
Okay, we'll start in step 3, and we'll call you on step 10.
Somebody read them.
Good plan.
Okay, I'm going to do 3.
On and Bravo on loop 1.
Yep, on Bravo loop 1.
In step 10, we want free on
Please.
Okay, we do not have payload water, so
skip 11 or
no prop valve loop 1 and 2 to
have them stop at that point.
Doesn't work.
Talkback should say payload.
It's going to be free on loop 2 only, and then we'll stop.
Right.
Okay, we'll tell them that.
Please.
Okay, up to step 6.
We need to do something as far as a purge on the...
2 switches to closed.
As long as
First one's closed.
pump on.
Closed.
Okay, check. Red bypass valve mode.
Okay.
And
It's not full, but I'll put it there.
Hey, folks, for post-landing, just
Probably has a check step.
we'll be getting in the nominal white page procedure.
all my fuel cell stack T messages. Keep going. Okay.
Route, we're going to go manual through the bypass for 3 seconds.
Concur.
And Discovery
Okay,
Houston
we'll do
Vegas, your fuel cell issues should clear up when we get through the evap out T low procedure.
Ready for step 9, Eileen?
Step 9.
Okay, FS controller, probably Alpha, Bravo, secondary, all 3 to OFF.
That's complete.
Deltas for step 10.
Houston, Discovery's on step 10.
Okay, Eileen, in step 10, we would like loop 2 only to Bravo. You can delete the 1, and then you can stop the procedure at that time.
Houston, we've got loop 2 in Bravo and complete.
Okay.
Nice job. Thank you.
This check, step 7 check, is actually,
Let's reconfigure.
normally you're going to go auto B on entry.
Certainly, it sound really loud outside because I can hear our voices outside the cabin.
Yeah, I thought that's what I heard.
Yeah, it was. Thanks.
We're ready for switch. Doesn't work.
Answer. Actually, a pretty dynamic kind of call. Yeah.
start ripping out 100% real quick.
This is Shuttle Control. Jacking and leveling of Space Shuttle Discovery in the Vehicle Assembly Building off of the VAB pedestals is continuing. About 15 minutes remaining in this process. You can see here that the mobile launcher platform is off the pedestals, and about another 15 minutes in the process to completely lift it to the position that's required for clearing all obstacles and rolling out of the high bay doors. No other operations or issues in work at this time. Rollout still expected to occur at 1:30 or very shortly thereafter. This is Shuttle Control. This is Shuttle Control. We're about 5 minutes away from achieving clearance height, lifting Discovery off the pedestals in the Vehicle Assembly Building. Once that's complete, we should be just a very few minutes away from first motion, so that should occur at 1:30 or very shortly thereafter. This is Shuttle Control. This is Shuttle Control, awaiting first motion of Space Shuttle Discovery. One of the rollout observers has flagged a possible obstruction on the zero level of the MLP with an associated platform in the VAB, so that's being checked out, and after that we should go for first motion. This is Shuttle Control. This is Shuttle Launch Control. Engineers are checking out a possible obstruction between the left solid rocket booster aft skirt, a line associated with the aft skirt, and a VAB platform. We're trying to assure that there will not be any interference when Discovery begins to move between that SRB flex line and the VAB platform. So that's probably going to put us up to about a 2 a.m. rollout. This is Shuttle Control. This is Shuttle Control. A solid rocket booster technician is adjusting the location of an SRB solid rocket booster flex hose that has a possible obstruction with a launch platform in the VAB. Estimate to complete that at this point is another 5 minutes or so. It's on the left-hand booster. And they're also double-checking that an adjacent hose on the opposite side of the booster won't create the same problem. Again, just a minor issue, but they estimate they need about another 5 minutes to complete that job and sign off on that task. So we hope to be rolling about 2 a.m. This is Shuttle Control. This is Shuttle Launch Control, ready for rollout here this morning. Word from the technicians on the mobile launcher platform, instructions are cleared. That status passed along to Launch Director Mike Leinbach here in the firing room. And he has given a go to roll. So we are awaiting now first motion for the rollout of Discovery to pad 39B. Once again, we have a go to proceed, a go to rollout. This is Shuttle Control, first motion of Discovery, confirmed at 1:58 a.m. And the expected arrival time atop the pad is 9 a.m. this morning. This is Shuttle Control, Space Shuttle Discovery on the way to the pad. The motion is very slow to begin with before it accelerates to the full 1 mile per hour that it will attain on the way out to the pad. The initial movement is very slow to assure that there are no obstructions. There are many observers on many different levels of the vehicle assembly building and on the ground, watching as the space shuttle clears the high bay doors of the vehicle assembly building. On the crawler transporter, the Space Shuttle Discovery stack and the mobile launcher platform weighs about 12 million pounds. And if you combine the Discovery and crawler transporter with the mobile launcher platform, that's about 17.5 million pounds moving out toward the pad. This is Shuttle Control. Launch Director Mike Leinbach has just received a weather briefing from Shuttle Weather Officer Kathy Winters. And weather is go for the entire duration of the rollout. There are some showers about 70 miles to the northwest and 90 miles to the northwest of Kennedy Space Center. However, these are stationary, not moving much at all, and there's no lightning associated with them, so they're not any kind of a threat to us today. Everything around the Cape is good weather currently and forecast to remain very acceptable for the duration of the rollout. Once Discovery is atop the pad, it takes about an hour to lower it down onto the launcher pedestals at pad 39B. And after that, the electrical and mechanical connections will be established. This is Shuttle Control. The crawler transporter that is taking Discovery out to the launch pad is powered by two 16-cylinder Alco diesel engines, each of which generates 2,750 horsepower. They are driving four 1,000 kilowatt generators that provide power to 16 traction motors. The crawler holds 5,000 gallons of diesel fuel, and it uses 126 gallons of fuel per mile. The belts that we see on the crawler transporter, these shoes or cleats each weigh about 2,100 pounds, and there are 57 on each of the 8 belts or treads that are on the crawler transporter. They've been refitted for return to flight with completely new shoes on each of the 2 crawler transporters. Discovery now out onto the crawler gouet gravel. This is about 8 inches of river gravel that crawler transporter is rolling over, and that river gravel sits on top of about 4 feet of crushed stone, and beneath that is another 1 foot of compact fill. This is Shuttle Control. All of the vehicle assembly building personnel and mobile launcher platform personnel that supported the first motion from the VAB have now been released, and the mobile launcher platform personnel will greet the shuttle at pad 39B once Discovery arrives later in the morning. From the Space Shuttle Discovery Rollout Command Center, this is Shuttle Control at 4 hours, 17 minutes, 12 seconds into the rollout of Space Shuttle Discovery. Discovery began its crawl toward Launch Pad 39B at 1:58 a.m. this morning. Since then, it has been making gradual progress with occasional stops to check bearing temperatures. One particular bearing is running slightly warm, and for that reason has required some extra lubrication and somewhat slower running by the crawler since the problem began at about 4 a.m. this morning. Right now, the crawler transporter is moving at a speed of 1/2 mile per hour. The nominal speed would be closer to 0.8 or 1 mile per hour. And the bearing temperature that we have been monitoring is stable at this time. The nominal temperature would be somewhere in the 90-degree range, mid-90s. It's run as high as 124. Anything above 120. The crawler team likes to stop and actually do a greasing of the bearing and an inspection of the bearing. Right now, the temperature is stable about 115 degrees, so they are considering moving the speed back up closer to 1 mile per hour if the bearing temperature that they're seeing at the moment remains stable. This is a similar problem to what we have with the rollback of Space Shuttle Discovery coming back from Pad 39B. However, this is a different crawler transporter and it is a different bearing location. At this point in time, the estimated arrival time of Discovery at Pad 39B is 12 noon. The hope is to get there no later than that because the increase of showers and chance of lightning goes up after 1 o'clock. And so we'll be watching here over the course of the next hour whether the speed of the crawler transporter can be increased, bearing on what appears to be stabilizing of temperature in that particular bearing. Otherwise, the Discovery is doing well on its trip to the pad. We're about 2.9 miles away from Pad 39B right now. At 4 hours, 20 minutes, 22 seconds into the rollout of Space Shuttle Discovery, this is Shuttle Control. This is Shuttle Control at 4 hours, 32 minutes, 30 seconds into the rollout of Space Shuttle Discovery. The crawler transporter is stopped temporarily while the temperature of the bearing is checked and extra grease is applied to keep the temperature of that bearing stable so that the speed can be increased up to about 1 mile per hour. It's been moving at about a 1/2 mile an hour or so while the temperature on that bearing is monitored. Currently, expectation is that Discovery will arrive at the launch pad at about 12 noon. Should be down, hard down on the launcher pedestals at 1 o'clock, and at that time they would immediately plan to rotate the gantry light rotating service structure into position around Discovery, which will provide the primary access and weather protection. On the crawler transporter, the Space Shuttle stack and the mobile launcher platform weighs 12 million pounds. And if we add the crawler transporter's weight to that, the entire stack moving along crawler weighs in at 17.5 million pounds. The crawler is powered by two 16-cylinder Alco diesel engines, each of which generates 2,750 horsepower. They in turn drive 4 1,000 kilowatt generators that provide power to the 16 traction motors. Crawler holds about 5,000 gallons of fuel, and as it moves along, it consumes 126 gallons of fuel per mile. Once Discovery is atop the pad, the laser system on the crawler transporter allows the mobile launcher platform to be positioned within about half an inch on the pad's launch pedestals. Once again, the rollout began at about 1:58 a.m. this morning, about 2 hours later than planned, due to no particular serious problems, just a little slow going in completing all the tasks necessary to retract all of the platforms away from Discovery, jack and level the mobile launcher platform, and take care of some other minor issues which came up during the preparations. So once the current assessment of the crawler transporter bearing state of health is determined, Discovery will resume its crawl toward the launch pad, hopefully at a slightly higher rate of speed, and temperatures will be monitored as we go along, but again, we expect Discovery to be at the launch pad at about noon. This is Shuttle Launch Control. This is Shuttle Control at 4 hours, 47 minutes, 15 seconds into the rollout of Space Shuttle Discovery. We've been cleared to increase the crawler transporter speed up to 0.65 miles per hour from 0.5 miles per hour based on the current evaluation of the bearing, which has been running slightly hotter than desired. Right now it's running between 110 and 118, and if it stays in that range, speed may be bumped up even slightly more yet, up to about 0.8 miles per hour. Also, the team at the launch pad has been advised of the approximate arrival time of Discovery at noon, and that will be their call to stations for the team for the afternoon's activities, which will include rotating the gantry light rotating service structure into position and begin the electrical connections, umbilical connections with the pad terminal connection room, and all of the mechanical connections and positioning of swing arms that have to be done. Weather up until 1 o'clock today is supposed to remain quite favorable, so no concerns on that front. However, there is a threat of showers and a chance of lightning after 1 p.m., so the desire is to get to the pad as close to noon as possible. To prepare Discovery for return to flight has taken 3.3 million man-hours of work, 8,000 inspections, and 25 pieces of flight hardware have been replaced or added to the vehicle. And we continue to target launch of Discovery on STS-114 as soon as July 13th. This is Shuttle Control, 6 hours 33 minutes into the rollout of Space Shuttle Discovery. Discovery is making a 10-minute stop for a repacking of the bearing that's been having a tendency to overheat throughout the rollout. So, in a sense, Discovery is making a pit stop on its final home stretch to the pad. This will only take about 10 minutes to do, and then the rollout will continue at nominal speed. And based on that, the estimate that the Discovery should be starting up the ramp at pad 39B is about 10 o'clock, between 10 and 10:15. And hopefully be up on top of the ramp by 11 o'clock this morning. So this is just a temporary stop to allow some additional grease to be applied to that bearing. This will take about 10 minutes, and then rollout will continue. This is Shuttle Control. This is Shuttle Control, 7 hours 32 minutes into the rollout of Space Shuttle Discovery. Discovery now moving at the speed of 0.9 miles per hour. Bearing temperature still reported acceptable to continue moving toward the base of the pad, which we expect to occur in about a half an hour or so. It will then take about another half hour, 45 minutes to go up the ramp, and hopefully the operation should be complete by about 11:30. No other issues in work, so Discovery is able to continue to keep moving toward the pad without any additional stops for bearing lubrication. Then starting up the ramp should occur in about another half hour or 45 minutes tops. This is Shuttle Control. This is Shuttle Control, 8 hours, 3 minutes into the rollout of Space Shuttle Discovery. The pad observers, which are used for the final movement into place of Discovery over the launcher pedestals, have been told to report on station at 11 a.m. That will begin the process of going hard down onto the pedestals. And at this time, we expect the Discovery to be within the pad perimeter fence and under the cone of protection of the pad lightning protection system within about the next 15 minutes. However, at this time, weather continues to be generally favorable until and for at least the next 2 hours. Once the Space Shuttle starts up the ramp, the speed will probably be reduced to about 50%, which is customary for going up the incline. And as the shuttle approaches the pad now, all the activities are going smoothly. This is Shuttle Control. This is Shuttle Control, 8 hours, 21 minutes into the rollout of Space Shuttle Discovery. We have confirmation now that the crawler transporter is moving up the ramp. This is something that occurs very, very slowly, less than half a mile an hour. And as that occurs, the leveling system on the transporter will be reacting to keep the space shuttle level as it goes up the incline. And at this point, the operation continues to be going well, going smoothly. Not very much talk on the communications channels here in the Launch Control Center. And this part of the operation does tend to slow down considerably. But it's anticipated that we should be on top of the ramp at about 11 o'clock Eastern. This is Shuttle Control. This is Shuttle Control, 8 hours, 50 minutes into the rollout of Space Shuttle Discovery. The crawler team reports that everything is functioning well as the crawler transporter takes the Space Shuttle Discovery up the incline at the Pad B ramp. This activity to reach the top of the ramp should take about another half hour to complete based on the current speed, and this is customary for the crawler transporter to move this slowly once it reaches the incline, and the leveling system on the crawler transporter has also kicked in to keep Discovery level as it moves up the ramp. Once Discovery is over the launcher pedestal, it takes about an hour to gradually lower them down onto the pedestals, and the crawler transporter can move less than 1/10 of a mile per hour to position it properly. And if there is a laser system that helps guide it down over the pedestals and into which the crawler transporter pins will be inserted, or the launcher pins, or the launcher platform. After that occurs, the next activity will be to move the mobile launcher platform or the rotating service structure into position. That's still currently scheduled for about 1 o'clock. That provides the primary weather protection and access for the shuttle, and they would like to get that moved in as soon as possible to provide some weather protection, since after the sea breeze kicks in after lunch, it is expected that some rain and thunderstorms could form along that sea breeze front. But right now we don't see any indication of that. The payload bay doors will be open tomorrow, and payloads will be installed on Friday. This is Shuttle Control, 8 hours, 59 minutes into the rollout of Space Shuttle Discovery. Discovery approaching the top of the ramp now, and underneath the cone of protection weather-wise from the pad lightning protection system, we're seeing our first indication that some cells are beginning to form as the result of the sea breeze beginning to kick in. So the timing of this has worked out just about as anticipated. So we'll be completely hard down on the pad, and the rotating surface structure will be in position before weather forms to the extent and moves into the Complex 39 area this afternoon. So this has all gone according to our desired plan. From the Space Shuttle Discovery Rollout Command Center, this is Shuttle Control at 9 hours, 17 minutes, 30 seconds into the rollout of Space Shuttle Discovery for STS-114. This is a live picture of Discovery as it approaches the top of Launch Pad 39B with a rollout that began at 1:58 a.m. this morning. The rollout was delayed due to some minor problems in transferring from VAB facility power to transporter power, and some additional time was required to remove all the access platforms and to resolve some minor clearance problems. Once rollout began at 1:58 a.m., it continued smoothly for a couple of hours until approximately 4 o'clock, when a stop was made to grease a bearing that indicated that it was getting high in temperature, and Discovery resumed its roll, after which another stop was made for another greasing of that bearing, and speed then resumed at 1 mile per hour until it reached the launch pad, except for one additional brief stop to grease that bearing that was showing a tendency to continue to run warmer than usual, and that was to keep it within the operating parameters. Discovery's speed on this rollout has ranged anywhere from 1/2 mile per hour to 1 mile per hour, but once the Discovery reached the ramp, it was reduced to less than 1/10 of a mile an hour for the gradual climb up the ramp, and it will now be positioned over the launcher pedestals, which we see in front of us in this picture. That will be the last activity today once the mobile launcher platform is lowered onto these pedestals. Once hard down is complete, then the gantry light rotating surface structure will be moved into position around the vehicle. That provides the primary access and weather protection, and that's anticipated to occur about 1 o'clock Eastern Time. Upcoming activities include the opening of the payload bay doors of Discovery tomorrow, and then the STS-114 payloads will be installed on Friday.